Right now, somewhere in a city near you, a construction crew is drilling into the ground. They'll go 2 meters, maybe 3, and then they'll stop, pour concrete, and call it a day. Here's what nobody tells you. That drill, that ordinary, unremarkable drill, has penetrated a greater percentage of the earth than anything humans have ever built or designed or dreamed up in 50 years of trying. Because the deepest hole ever drilled in the history of our species is 12.2 kilometers, and the Earth is 6,371 kilometers to the center. We have scratched 0.19% of the way down. We haven't even broken the skin. In 1970, the Soviet Union launched what they believed would be one of the great scientific achievements of the 20th century. A drilling project on the Kola Peninsula in the far northwest of Russia, close enough to the Norwegian border that you could almost see it from there. The goal was simple: go as deep as possible, learn what's down there. They drilled for 24 years, and what happened to them is one of the strangest stories in the history of science. Not because of what they found, though what they found was extraordinary, but because of what stopped them. It wasn't money, it wasn't politics, it wasn't a lack of will. The Earth stopped them, and the Earth had tools they hadn't anticipated. Before Kola, geologists had a clean picture of what the crust looked like. You'd drill through granite near the surface. Deeper down, around 10 or 12 kilometers, the granite would give way to basalt, denser, more primitive rock from a different era of Earth's formation. Below that, eventually, you'd reach the mantle. It was a tidy model. It was wrong. The first surprise came before 7 kilometers. At that depth, granite doesn't behave like granite anymore. Under 1,000 atmospheres of pressure, rock stops being a rigid solid and starts behaving like something between caramel and very slow-moving putty. It doesn't crack, it flows, it yields, and then the moment you remove the drill, it flows right back. The borehole was healing itself. Engineers would pull the drill string to the surface to change a worn bit. This took an entire day because they were lifting hundreds of tons of steel tubing, a column that stretched 12 kilometers straight down. When they lowered the drill again and tried to re-enter the hole, they would find it had narrowed. In some cases, it had nearly closed. They were fighting the planet for every meter they kept. Then came the heat. Scientists had predicted that at a depth of 12 kilometers, temperatures would hover around 100 degrees Celsius. They built their equipment accordingly. They chose their materials, specified their sensors, and designed their instruments around that number. What they found was 180 degrees Celsius. Not a rounding error, not a minor miscalculation. The Earth was nearly twice as hot as the model said it should be. At 180 degrees Celsius, most electronics cook. Drill bits that were engineered to handle moderate heat began to deform. The lubricating fluid pumped down the borehole to cool the drill head would flash to steam and surge back up the pipe. Instruments failed, sensors went dark. And here's the part that really kills the dream of going deeper. At 15 kilometers, the steel column would not need heat to fail. It would snap under its own weight. Gravity becomes an engineering problem. A 15-kilometer column of steel tubing is so heavy that the metal at the top can no longer support the load below it. Even if you solve the heat, even if you solve the pressure, even if you invented drill bits that never wore out, the column would tear itself apart before it got there. We had hit a physical limit built into the properties of steel itself. But the engineers at Kola weren't thinking about that yet. They were thinking about something else entirely. When they pulled cores of rock from 6,700 meters, that was not even halfway to where they eventually reached, and they found something that shouldn't have been there. Water. Not surface water, not groundwater, not something that had trickled down through cracks over centuries. Ancient water. Fossil water. Water that had been locked inside that rock for 2 billion years, compressed under unimaginable pressure, chemically altered into something barely recognizable as the stuff you drink. And it was under such enormous pressure that the moment it found the open channel of the borehole, it flashed instantly to steam. It surged upward and nearly destroyed the equipment. The geologists had been absolutely certain there would be no water at that depth. The rock was supposed to be monolithic, sealed, dry. They were wrong about the water, and then they found something that made the water seem almost ordinary. In the rock cores, pulled from over 6,700 meters, biologists found fossilized remains of microscopic organisms. 24 species of ancient plankton preserved in rock that was 2 billion years old. 2 billion years. Life had existed in the deep crust. Not near the surface, not in some warm, shallow sea. Deep inside the crystalline basement rock of an ancient continent where there was no light, no oxygen, no reasonable explanation for why anything should be alive. And it gets stranger. Later research, not at Kola, but in gold mines in South Africa, found living bacteria at 5 kilometers depth. Not fossilized, living, growing, reproducing, metabolizing, surviving on hydrogen gas produced by the slow chemical reaction between rock and water, no sunlight, no connection to the surface biosphere, a completely separate ecosystem running on the chemistry of the deep earth. The boundary of the biosphere, the zone where life exists, does not end at the surface of the ground, it extends kilometers downward into the rock. We had been mapping life in the wrong direction. While all of this was happening, while the scientists were reckoning with ancient water and impossible life, the acoustic sensors installed in the borehole picked up something else. The deep earth is not silent. At 12 kilometers, the rock is in constant motion, not the violent motion of an earthquake, something slower, more continuous. Pressure gradients shifting, gas pockets compressing and releasing, granite under 1,000 atmospheres creaking like the hull of a submarine in deep water. The sensors recorded long, low groans, sharp pressure releases, what sounded, when played back, like something enormous settling. An urban legend spread across the world in the 1990s claiming that Soviet scientists had lowered a microphone into the Kola borehole and recorded the screams of the damned. The tape circulated on radio stations. People believed it. It was fabricated. A Finnish Christian radio program had made it up. But the real recordings, the actual acoustic data from Kola, were arguably more interesting than the legend. Because buried in the noise, scientists found evidence of gas reservoirs at depths where no model had predicted them. Pockets of hydrogen and methane under pressures that should not have allowed them to exist, essentially invisible to every surface survey technique. The borehole heard them. And then, when the project was at its most productive, when the data was pouring out and the questions were multiplying faster than anyone could answer them, it ended. Not because they hit an insurmountable wall. Not because the drill finally gave out. The Soviet Union collapsed. Funding evaporated. The crew dispersed. The equipment sat idle, then rusted. The borehole was capped with a metal lid that today sits forgotten in a weed-covered lot in the Russian Arctic. The deepest hole in human history was abandoned by an event on the surface 7 kilometers above its bottom. We didn't hit the limit. History did. You would think the lesson from Kola would have redirected ambitions, and in one sense, it did, toward the ocean floor. Here is the logic. The continental crust is 40 kilometers thick. That is why we cannot drill through it. But oceanic crust, the rock beneath the deep ocean floor, is only 5 to 7 kilometers thick. The math looks better. The path looks shorter. There is a reason that reasoning is seductive, and a reason it keeps failing. The first attempt was the Mohole Project, launched in 1961 off the coast of Mexico. American scientists chartered a converted naval vessel, positioned it over deep water, and started drilling through 4 kilometers of ocean before touching rock. Imagine trying to drill a hole in the floor of a room while you are hanging from the ceiling from a rope that is swaying. That is roughly the engineering challenge of drilling from a ship. Any current, any swell, any wind shifts the platform. The drill string, already kilometers long just to reach the sea floor, flexes and wanders. Hitting the same small hole twice, after pulling the drill to change a bit, requires threading a needle from kilometers away in moving water. The Mohole Project drilled 183 meters into the oceanic crust before it was canceled. Congress cut the funding in 1966. Japan tried again, decades later, with a purpose-built ship called the Chikyu. 30 stories of drilling equipment sit on a vessel held in place by satellite-guided thrusters accurate to within centimeters. It is the most sophisticated drilling platform ever constructed. In 2012, the Chikyu drilled 2,111 meters below the seafloor, a record for scientific ocean drilling. The Mohole, the boundary between crust and mantle, sits 5 to 7 kilometers below the ocean floor in most places. Humanity's best effort got roughly a third of the way there. The oceanic crust is harder than the continental crust. The basalt is denser. It destroys drill bits in hours. Every tool change is a multi-day operation, and the gas pressure building in the rock below is unpredictable. Bore into the wrong pocket, and the borehole becomes a geyser of superheated mud and methane moving at speed. The shortcut is harder than the long route, and so here we are. Everything humans have ever drilled, mined, tunneled, or descended into, every shaft, every borehole, every cave, exists within the outermost shell of this planet. The deepest mine on Earth, the Tautona gold mine in South Africa, reaches 3.9 kilometers. At that depth, the rock temperature is 60 degrees Celsius without ventilation. Workers need refrigerated suits to survive their shifts. The Kola Superdeep Borehole at 12.2 kilometers is the absolute outer limit of what we've physically reached. The mantle begins, on average, 40 kilometers down. The outer core is liquid iron, 4,000 degrees, and it is the dynamo generating Earth's magnetic field. It is 2,900 kilometers down. The inner core is 5,100 kilometers down. Solid iron, 5,400 degrees Celsius, pressures of 3.6 million atmospheres. There is no material humans know how to make that survives those conditions. The inner core will almost certainly never be directly sampled. We know more about the surface of Mars than we know about what's 50 kilometers beneath our feet. But here's what makes that fact matter beyond scientific curiosity. The mantle isn't inert background rock. It's the engine driving everything we live on. Its slow convection currents are what moves tectonic plates. Those plates create earthquakes, volcanoes, and the carbon cycle that keeps the atmosphere stable. We predict earthquakes with less accuracy than we predict weather, not because we lack the math, but because we cannot observe the mechanism producing them. We're watching waves on the surface and trying to understand the ocean we cannot see. The magnetic field that shields every living thing on Earth from solar radiation is generated by the fluid dynamics of the outer core. It has been weakening and shifting. Its northern pole has moved more in the last 30 years than in the previous century. We don't know why. The answer, if there is one, may be thousands of kilometers below us, permanently beyond reach. Right now, a new generation of researchers is designing what they call the M2M mission. Mantle to Mohole, a renewed attempt to pierce the oceanic crust and retrieve the first direct sample of mantle rock ever collected in place. Not ejected by a volcano, not inferred from seismic data, actually extracted. They are designing drill bits made of materials that did not exist when Kola was drilled. They are building thermal management systems that can operate continuously in temperatures that would have ended the Soviet project in a week. They might reach the Mohole within a decade, or they might discover a new obstacle that nobody anticipated, the way every previous project did. Because that is the pattern. You plan for what you know, you encounter what you do not. Go back to that construction crew, the ordinary drill, the 2 meters of sidewalk. That drill is doing something humans have been doing since before recorded history, pushing downward, trying to understand what is underneath. We have pushed 12.2 kilometers. We have found living things where life should not exist. Water sealed since before complex life evolved. Sounds coming from rock moving so slowly it took 1 billion years to get where it is. And we are not even through the crust. The planet is patient. It has been here for 4.5 billion years, and it holds its secrets at depths we may never physically reach. Not because we have not tried hard enough, not because we have not been clever enough, because the Earth is simply bigger than our reach for now. If this made you look at the ground differently, subscribe. We go deep on everything.